Alrighty, so organism effects, late effects of radiation. This again is part 2, last half of the chapter. Alright, so let's start off. Late effects take months or years to manifest. That's what we mean by late, okay? So it's just when in time the effect happens compared to when the exposure happened, right? So if the exposure was a week ago and the effect happens, that 7 days later, then that's an early effect. If the exposure was years ago and you develop cancer, 10 years later, it's a late effect. Late effects take months or years to manifest, and we say they generally tend to follow the linear non-threshold response curve. That's important to get that right? So with these linear response curves, what we mean is that the probability of you developing the effect, which we're going to talk about all these different effects, but the probability of you developing the effect goes up proportional to your dose. Double the dose, double the probability of the thing happening. Okay. Notice it doesn't talk about severity. It doesn't say how severe a type of cancer or cataract will be. It just says your chance goes up with increasing dose. So it's all about probability. You see, if we kind of zoom in on the response graph, it's showing percent incidence as the vertical axis and dose as the horizontal axis, and the line that's plotted takes a straight diagonal approach, meaning that as dose increases, probability increases. Okay, so some of the first ones we're going to talk about are offspring effects, are effects to the offspring, not to be confused with what they call mutagenic effects that happen prior to conception, that would happen to the ovum or sperm. The effects we want to talk about first, we're going to call them teratogenic, and these are effects that occur to a developing embryo or fetus from exposure, in utero, as they say right here, in utero exposure. So first, let's briefly break down what we mean by embryo or fetus, because we're going to sort of get into this a little bit, but it's not made super explicit through the notes. For this, I'd like to split the gestational period into 3 different chunks, and I don't mean first trimester, second trimester, third trimester. Okay, what I mean is 0 to 2 weeks. We call this the germinal stage. This is where you go from essentially a unicellular organism to multicellular organism. This is what they typically in these texts will call the blastula stage, the stage where the cells are just basically rapidly dividing. The thing doesn't look like anything yet. A couple of weeks. Okay, germinal stage. From 2 to 8 weeks, we're going to call that the embryonic stage. In this set of notes, I believe they refer to it as the organogenesis period. Okay, the period where things are starting to get put together. Okay, and then the fetal stage from 9 weeks till birth. And we're using human gestation time frames here. Okay, so assuming like a 9-month gestation period. Okay, all right. So anyways, I like to split that up into 3 stages: germinal 0 to 2 weeks, embryonic 2 to 8 weeks, fetal stage 9 weeks through birth. Okay. So when we say embryo or fetus, we mean things that are happening after those first couple of weeks, okay, in the embryonic or fetal stages. In utero exposure to a developing embryo or fetus during these stages poses significant risks to that offspring, but importantly, not to be confused, as I just said, not to be confused with mutagenic effects, which can occur from radiation exposure to the gametes, the sperm or ovum, prior to conception. So sperm or ovum get radiation exposure, some mutations happen, those mutations build an offspring that has some defect, some problems, okay? If those gametes, sperm or ovum, are not exposed to radiation, and those are used to conceive an offspring, to develop an embryo, but then the embryo or fetus is exposed to radiation. Those are teratogenic, the ones that are the exposure in utero to the developing embryo or fetus. These effects are going to be a slightly different to the late effects rule because these follow a nonlinear and threshold response curve. So this is a different thing. This is a contradiction to the typical late effects are stochastic and random, no threshold, linear response. These teratogenic effects demonstrate a threshold and they demonstrate a nonlinear response. So these are all these rules we talk about are, rules are meant to be broken, right? So these rules are broken on occasion. This is an example of that. Biology is complicated, let's say, okay? Okay. We're going to talk about 4 different types of effects that happen to exposure in utero. And the reason why we're doing all of this is to remind you that there's a period of time during gestation, during embryonic and fetal development, that poses, if exposure to radiation happens during these times, it poses a serious health risk to that developing embryo or fetus. So, yes, please.
Just with the
Teratogenic, yeah.
That happens, say I'm not pregnant, but I go in and get x-rayed. Later down the road, my offspring could have some type of mutation from that exposure from that radiation?
Yes, that's mutagenic.
Okay, and then I have a question. And then I think I got it.
Okay, so yeah, there's two things, right? If you're exposed to radiation and then you conceive a child, and that child has some birth defects because the gametes were exposed to radiation, that's a mutagenic effect. Okay, the exposure happened before the offspring started to develop. Okay, if the exposure happens after the offspring begins to develop, we're going to call those effects teratogenic. Those effects, teratogenic effects, do demonstrate a threshold, do not demonstrate a linear response, as in they demonstrate a nonlinear response, and those are what we're talking about right here. Yeah, we're gonna talk about the mutagenic effects here in just a little while. Okay, so we want to list 4 different possible things that can happen. Number 1, starting with spontaneous abortion. Okay. Otherwise known as reabsorption. Number 2, congenital abnormalities. These are physical defects present at birth. Number 3, mental retardation. And number 4, latent carcinogenic effects. Latent means demonstrating a period of time where the effects are not happening, and then all of a sudden some carcinogenic process happens, or early childhood cancer. Okay, so depending on when the exposure happens, depending on when in time these exposures happen, one of these 4 becomes more or less likely. So, in the first 2 weeks of gestation, what I refer to as the germinal stage, the only radiation risk to the developing blastula is spontaneous abortion. Okay, so radiation exposure during this time, either the embryo is completely reabsorbed by the body, either the blastula is completely reabsorbed by the body, or the offspring develops without any issues. So this one is an all or none. Okay, the embryo is either destroyed or survives without any complications. This is an exception to the exception. Unfortunately, biology becomes complicated, okay? So we said that teratogenic effects demonstrate a threshold, demonstrate a nonlinear response, which is an exception to the rule of late effects, okay? This is an exception to that exception, okay? So this one goes back to being an all or none, either does or doesn't happen phenomenon, low probability stochastic effect. We say it's estimated that a dose of 100 milligray increases the already existing normal spontaneous abortion rate by 0.1%. 100 milligray would be something that is possible during like a barium enema study, certain fluoroscopy procedures, CT scans. It takes significant amounts of radiation to reach 100 milligray. Nothing that we're going to do with our single film exposure type that we do at diagnostic X-ray exposures. But it's possible in radiology to reach these exposure levels to that developing blastula. So definitely possible. But if you look, it increases the spontaneous abortion rate by 0.1%, right? That's 1 in 1,000, right? From the already existing spontaneous abortion rate of 25%. That means 1 in 4 pregnancies spontaneously abort without the female ever knowing that she was pregnant. This is in the first couple of weeks. You don't typically know you're pregnant in the first 0 to 2 weeks after the last menstrual period begins, right? 1 in 4 spontaneously reabsorbed. A dose of 100 milligray increases that by 0.1%. So that's really the only risk during that stage, which is nice, right? Either the embryo is completely reabsorbed, nobody knows anything happened, or it develops without any issues, which is also good, okay? The 2 to 8 week period, this is the period where we have some of the biggest risk for congenital defects, congenital abnormalities, okay? Because during this 2 to 8 week period, and let me pause here for just a second, I'm getting ahead of myself. We talked about a couple of different studies, right? We talked about Bergoni and Trabando. We talked about Ansel and Weidenberger. But importantly, Bergoni and Trabando. They talked about cell sensitivity based on a couple of different things, right? What was one aspect of Bergoni and Trabando's study that made a cell more or less sensitive to radiation? What was one controlling thing? What did you say? Not water. What's something that makes a cell more sensitive to radiation than another cell, than any other cell? Increases sensitivity. The age, right? What we roughly mean by that is the level of specialization or differentiation, right? Undifferentiated cells are more sensitive to harm than differentiated cells, okay? That was one thing. There was really two important things. That's one of them, the degree of specialization. Undifferentiated, non-specialized cells are more sensitive than the specialized differentiated cells. What's the other thing? What do cells have to do to produce new cells? What do we call that? Replication, or it starts with an M. Mitosis. Good. So mitosis, the rate of mitosis, right, is the other factor in determining cell sensitivity. Cells that are highly mitotic, cells that divide frequently, are more sensitive than cells that divide less frequently. Yeah. During organogenesis, as well as during those first couple of weeks, but importantly during organogenesis, you have undifferentiated cells rapidly dividing and differentiating. In 2 to 8 weeks, you go from an undifferentiated, blastula blob of cells to a well-differentiated structure with purpose, right? With organs that look like organs, and it starts to look like a thing, right? It starts to look like a real organism. That's why we call it the organogenesis period. This is where the body parts are starting to get put together. In more intelligent terms, tissues are differentiating into identifiable organs. Organogenesis. The main risk during this period is congenital deformities, congenital defects. So it's a good time to pause and make sure we all understand what the word congenital means. So can anyone help us out? What's the word congenital tell us? Not identical. Congenital means an effect that you're born with, or defect that you're born with, right? Cleft palate is a congenital defect, okay? Spina bifida is a congenital. These are things that you're born with, right? These can be from genetic mutations, but it's an effect that you are born with, okay? It's not something that happens after birth. I don't have my key, can't help them. Okay. Okay, so the main risk during organogenesis, congenital deformities. Now, 6 in 100 births happen with congenital deformities already. This. Hi.
I need to talk to you really quick.
Oh, okay.
Sorry.
That's okay. Let me pause.